we are going to talk about derivatives presented analytically and graphically. Essentially, the important thing here is that the graph of a function can be used to make determinations about its derivative. A function is increasing at a point if f prime of x is greater than 0. The function is increasing. And if f prime of x is less than 0, the function is decreasing at that point. And critical numbers are defined to be where the derivative of a function is either undefined or equal to 0. So I'm going to sketch the graph of a function here. So there's a function for you, and we are going to look at the graph of this function and make some determinations about its derivative. This function is increasing from negative infinity to negative 4 and from 1 to infinity, so its derivative is positive from negative infinity to negative 4 and 1 to infinity. Also, the function is decreasing from negative 4 to 1, so its derivative is negative from negative 4 to 1. This is just an example of how we can look at the graph of a function and draw some conclusions about its derivative. An analogy that I kind of came up with here to make you think about this is impressions of people. A lot of the time, if you just meet someone briefly and get a first impression of them, a lot of the time you can tell, at least to a certain extent, what the person is like without really knowing them that well. It's sort of like this in the sense that you don't know everything about the derivative just by looking at the graph of the function, but you know certain characteristics of the derivative. Things that are important about the derivative you really know. And so, in general, it's important to be able to analyze a function and its derivative based on the graph of the function because it just really tests your knowledge of differential calculus. And so that is some information about derivatives presented analytically and graphically.